the space button. Now you see, as I told you, it's always going to the tip of the wizbot and it's going away from the wizbot to sense if something is in front of it. Hi friends, so in my last video you might have already seen that I have created this simulator for maze finder robot. So how does it works and how I made this happen in the PictoBlox, where you don't have any simulated sensors like ultrasonic sensor or line following sensor, IR sensor and all these things. How did I made it happen? What was the trick? So I'm going to explain all these things in this video, and let's start. So first of all, I will click on this flag to initialize the position, and now I will press the space button to make it go, and that's all. I'm moving my hands up. It's doing of its own. I'm not doing anything. The logic, the code is doing what it does. And if you see, let me fast forward this. See how it took the turn. It checked all the directions and then it decided to come this side. Let me move, otherwise it will hit me. Okay. So yeah, so that's how it will go, and let's see the last moment and then I think we can stop it. But yeah, it didn't mate to the apple. For that you have to write a proper code. This is not the right code that can make him reach to the apple. I'm not concentrating on how to solve the game, that is up to you, but how easy it is, that's what I'm going to explain. So okay, let me stop the game and come out. So here is the arena, or here is the place where you can write your code, and see it's so clutter free. You don't see the internal details, how I have implemented the wizbot, how is that logic of sensing the front thing. You just got the variable, just use it. You just go left, right, how to go left, right, everything I have made as a function. It's a black box for you. How it's really turning left or right, it doesn't have to bother about it. All these internal details I have hide. So how I have hide, where are those codes, I will show that. But before that, this is your play area where you are actually playing, and these are the blocks you are feel free to use. Backward, forward, left, right, and sensor, sense if going over the wall, and sense obstacle. So these are the items you have for you to use, and obviously you can use all the events and the controls, because without if and else you cannot do anything, right? So yeah, this all you have access. But now let me go to how I have implemented this left, right and all this thing, and how I am sensing if there is something in front of you. So let's see. For that I will go down, and these are the internal details how it was working. So this is the sense obstacle function, and what it does I will come to that. But before that, let's see how it moves, because from every time movement, whenever I move, I just call sense obstacle after the move. Say for example, I turn left and then I say check sense obstacle, or backward sense obstacle, then forward, right. So left, right, forward, backward, every time I go there I'm trying to sense if something is in front of me or not. So here is a trick, like how can you sense if something is ahead of you, I mean without touching, without having this sense block where you see touching the color. So you are not touching the color, because if your robot touch the boundary, that's all, it's done, you hit the wall already. So you should not touch, and without touching you have to know where is the black color. That's the challenge, right? So how I solve that, I will come to that. So first of all, how I am moving left and right and forward, I guess it's easy. So move how many steps. So this is the speed control. You can try to move faster, but best there will be best possible coordinate. You can choose that so that the game doesn't finish very fast, or it try to jump too fast and jump onto your line. So yeah, that you have to tune. For me, the next step is initialize. So this is my initialization variable where I'm setting everything. So for me, I saw 4 pixel works better for me. Okay, so let's see how the forward, backward, left, right code is written. So first of all, I am moving in the desired direction. It moves, and then once I move, then I'm checking sense if going over the wall. So once I am already moved, then I'm checking if I am touching the black color. So if I'm already on the boundary that I should not, then if I sense it, I will go backward. Whatever I have done, I will just do undo. So this is a trick that happens so fast that you don't understand, which is otherwise a wrong step. Physically, practically, your robot cannot do this, right? You cannot undo what you have already done in physical world. But that I am doing just for the animation purpose. I mean, just for hiding the complexity. But yeah, if you have a better way of doing it instead of going, and there is better way. Without going, you can find out what is there, and that's what I'm coming next. So that's one. And then if you undo, if you are not really on the boundary after applying that forward, backward, whatever, then you're okay. You just keep that undo part. This is the undo part. So everywhere there is undo part. For backward, moving forward is undo. For forward, moving backward is undo. For right, moving for left and right, actually you are not hitting anything, so you don't have to check for this because you have clearance in all the side. So that's what. And how I have a clearance in all the side, because in the costume, if you go, I have actually created a boundary around the wizbot so that they have a proper clearance in all the side. Okay, so that is also hidden because I have used the same color as the background. Okay, so now coming back, so this is okay, I believe. Now the main part is this is the magical part: sense obstacle sensor range. So this range, and what is the sense obstacle, that's I'm going to explain you now. So for that, let me go to the paint, and I have taken a screenshot of my arrangement. Let me zoom it, and now I'm going to explain. So look at this, there is an invisible small dot of the background color. That is a separate sprite, which is not the robot itself. Imagine that sprite is the photon coming out of your IR sensor, or that is the sound wave coming from your ultrasonic sensor. So what it does, it travels forward, like it will go forward, and at every step it have to check, am I on a black color line, like that, keep checking. So if anywhere in the middle it senses the black color, anywhere, be it anywhere, that means it should not go through. It have to stop, or it have to tell him that the range you have given, this is the range. So you have to tell how much far you want to see. So within that range, anywhere if it encounters a obstacle, it should not go forward, it should take a decision. Okay, that's the idea. So for that, what I have done, suppose, okay, I'll run through another simulation where I will move this guy forward in the paint so you can understand, just bear with me. So this one, and then you have defined the range as, suppose, 20 pixels. Let me use a different color, 20 pixels. So within this 20 pixel, at every step, every 1 pixel, or maybe you can define how many at every how many step, it will check if there is a black color. And yes, there is a black color at this step. So 1 2 3 4 5 6, at 6th iteration of for loop or some loop, it found there is a obstacle. Once it finds it, what it does, so for that, okay, sense obstacle is this is the sprite. Okay, this is the sprite, and first of all, I move the sprite wherever is this wizbot, wherever the wizbot is. I know the location of the wizbot, it is broadcasted, or it's a global variable. I know where the wizbot is, and it's a big area, right? Wizbot takes a big space, so you cannot say wizbot is at this location. It's actually a big location. So but wizbot will tell I am here. This is the pinpoint location where wizbot will say I am here, but actually you have to move this sensor somewhere here. If not, then it will detect this black color. These buttons are also black color, right? It can detect this black color and say I found a boundary. It should not happen. So you have to add some value of x, sorry, this is the y direction, right? So you have to get the wizbot location and add plus some value of y to get a new y for your new sprite, this sensor, and for x this is same. But wait, this is only when you go forward. If your whizbot is turning in the other side, if your whizbot is turning, suppose you rotated this side, then if you go forward, if you want to go forward, then it's x direction. So that's, keep in mind, this is a challenge I had while doing this, while developing this code. So if you are this side, you see your, instead of your y getting added, your x will be getting added. X equal to your whizbot xw plus the pixel amount you want to move. So that pixel amount, that is your new location for your this sprite. But y equal to whizbot's y equal to your sensor's y. So xs sensor x location of the sensor is whizbot's x location plus how much pixel you have to move forward to come to this tip. So this is the location calculation I'm doing, starting from here and facing which direction your whizbot, because you can anyway access your whizbot orientation. This is the 90-degree, right? So you know this direction, and based on that you can find out which direction your whizbot is, and based on that you can decide I should add in x or I should add in y, and I should add or subtract, because again there is a challenge. If your whizbot is turning, this way, this is again y direction, but it's a minus negative y direction. So you have to keep in mind negative positive both y and negative positive both x direction. So that's another challenge. So this all are taken care into this sprite. So this all the details are hidden from the students doesn't have to bother about it, but the teacher who is implementing this, or I'll be already sharing this in my Google Drive. You can take it, but if you want to modify or tweak it, please do share with me your new learning, or if you have enhanced it. But this is how it is going to work ideally. So this is the place where I'm finding out which direction your whizbot is facing. It is, if the direction is 0 degree, you see this is the whizbot is now turning in this side, left side. Okay, so that means, and the degree is minus 90 degree. So you see here minus 90 degree is pointing to left direction, and if it is left, then your new x will be your dot x status, start and end. So what I'm doing, I'm defining your this sensor's starting position, x and y. So start x, start y, and then end x, end y. So I am defining the starting point in the xy coordinate and ending point in the xy coordinate, and the work, and this is a global variable, this dot x start, dot x end, and all these 4 variables are global, so this dot can access them. And what he have to do actually is to start from one of the direction to the other direction. So in one case the direction will be towards the x, so it will be x plus plus plus, and y has nothing to do, or it have to do y plus plus plus, y plus or y minus. So this is the place where you are checking if x start and x end is same. That means it is expected for you to move only by y direction. If y is same, then you are expected to go by y direction, and every time you add a step this much. So the step is 1 here. Every 1 pixel I am checking if there is a black color or not. Every time you do that, and then you check if you exceed the end. So you should not be super sensitive. The ultrasonic sensor, it has a range, and in your code, in your whizbot code, while you are writing that, while you are saying that okay, I want to see if any obstacle is in front of me or not, you are defining obstacle sensor range is how many pixel. So it can see up to 10 pixel in front. Even if it rotates the other side, it can see up to 10 pixel in that direction. So that is the range I have defined. You can define your own range based on your maze, based on your multiplication factor of the maze. You can define what should be your better value. Okay, so yeah, it is configurable. That's what I want to share. So if you can just change this place alone, your ultrasonic sensor will be that much sensitive, how much you mentioned there. Okay, so that's what. And then with that, This guy will keep moving left and right, and you will see things happening. So now you know this, and I was hiding this. Now let me unhide. Let me not hide this. Let me change the color such a way that you can see clearly something is happening, just to understand, just to have a fun. And let's see, as I explained, is it really working that way or not. So I'll go back, click flag, and press the space button. Now you see, as I told you, it's always going to the tip of the whizboard, and it's going away from the whizboard to sense if something is in front of it. Why? Because PictoBlox so far doesn't have a way to know at any pixel, given any XY coordinate, what is the color. So this is the way I overcome this. But I have spoke with Stempedia. They have they accepted that it's a good idea, and they might add it in the next upcoming release of PictoBlox. So once it is there, all this complexity will be reduced. You don't really have to come up with this kind of one sprite trying to find out in front what is there and all. You don't have to think about all this thing. It will be taken care very instantly, and once it is very instant, your whizboard will really move faster. You see, the whizboard is little struggling to move. You have to see a lot of you have to wait for a long time to see the whizboard moving till the destination. So this one can improve once you have a dedicated get color pixel at any given XY, that kind of block. So yeah, I think they will come up with that. Until then, this is a workaround, and it's really working. And what is that maze solving final answer? It's up to you. You find out and let me know. So with that, I believe you understood how I implemented this and what next. So this is just the ultrasonic sensor. You can make your IR sensor to do a line following robot. So instead of having only one sensor, in my case, you can have two sensors throwing from both sides, and any one of them getting that black color line will make him turn. Easy, right? It may not be that easy like the ultrasonic sensor, because in ultrasonic sensor I have ensured I am only turning every time 90 degree. But if you are planning to turn as per the curve of that line following robot, and if it is not exact 90 degree, you really have to take care. You really have to take care of so many angles. So it will not be that simple like I did x position minus y or y x position plus y. You have to do some cos theta sin theta to really going to that direction of x and y. So I am leaving it on you. If you have any hurdles, please contact me in my WhatsApp. I will be happy to help you. Okay, so if you can make it, I will be very happy to see if you have done that line following robot using that. And that's a challenge I'm throwing, and I believe you will be interested on doing that. Please show your interest in my video, so that I can make more such innovative things for you. Bye bye Whizbot. He is also leaving. I think I also have to leave. Oh, he's not leaving. That's good. He should not leave the pavilion. Okay, so I think at some point he will find out, but no, this is not the logic that he can finally get through. Why, you might be knowing. If you don't know, maybe write down in the comment section. I will tell you why it can never solve this maze. Yeah. So with that, I will stop this video. Thank you so much. Bye.